Okay, so we're looking at this problem here from the review sheet. We've got the pulleys, or the one pulley actually, sorry, and the two blocks on the ground. So we want to find the range of values of this force F that's applied to the pulley to pull upward that will cause block B to lift off the ground, and the range that will cause block A to lift off the ground. So this is, well, we're going to start by looking at the pulley. So let's do an FBD of the pulley. That could be better. All right. So an FBD of the pulley. The pulley, there is. I kind of wish this thing was bigger, but I mean my drawing thing was bigger, but whatever. So this applied force F acts upward on the pulley, right? And then let's just draw a little thing around the pulley here. So we got the applied force F acting upward, and then we've got two cables coming off of it. It's the same cable, right? But it's wrapped around the pulley, and both ends come off of it. So we've got that, and the tension in one, and because this is a cable wrapped around a massless, frictionless, etc. pulley, they both have the same tension. So we don't need to do any component breakdown because we've got everything along axes, and we have, of course, the obvious coordinates here. So then we can go here and go sum of forces on the pulley equals mass of the pulley times its acceleration. Oh, why haven't I drawn the weight of the pulley in here? Well, because it's massless. So there's no weight for the pulley. Okay, so then sum of forces in the x direction equals 0. Well, no, actually, I mean, technically I should write, but actually we don't have to write this at all, I guess was my point. Poorly made though it was. Okay, so sum of forces y on the pulley is mass times the pulley's y acceleration, and we plug things in there. We get that the force, this force F applied upward minus the tension going downward twice equals, and then the mass of the pulley is 0, okay, times AY. So it doesn't matter what the acceleration of the pulley is. The tension in any of the, or in either side of the rope is always going to be F divided by 2. And that then makes it actually pretty easy to solve the rest of it. So if you want to, if you want to really go through and find, let's do an FBD for block B. Okay, then we have here, there's block B has its own weight, which is its mass m times g, and then you've got the tension from this thing going up. Okay, and of course then sum of forces equals ma, and sum of forces, let me put coordinates on there, x and y. Sum of force in the x direction, who cares? You can skip the component direction, you can skip one of the components of Newton's second law if there are no forces acting in that direction. Okay, so the sum of forces in the y direction, we've got, MAY, and then we've got, tension going up minus mg going down equals the mass times AY, and why am I cramming it in on the right side of the screen? Because I feel like it, and why did I do that? Because I'm clumsy. So, and this is also me being clumsy. So then you can say find F over 2. Oh, what the hell am I doing? Holy crap. Guess what I forgot? There's also a freaking normal force on the ground. Hello. All right, so that, and then there's a normal force on block B. Wow, okay. So then we have the normal force going upward plus that, so now I've recovered. Wow, I am horrible. Okay, so F over 2 plus that normal force minus mg equals MAY. So this is for block B, and I'm just going to call this, I'm going to say, if it's accelerating upwards, its acceleration is AB, so AY equals AB, so then this is MAB. Okay, so what are the possible accelerations for AB? Well, it can't accelerate downward, right? So AB can't be less than 0. So in the case where AB equals 0, okay, so AB equals 0, then what do we have? Well, we've got F over 2 plus the normal force on block B minus mg equals 0. So in that sense, whatever you did, the normal is going to be m. Oh, sorry, that's not a good equal sign. So let me just go down here and say the normal force on block B is going to be mg minus F over 2. And finally, then, what's the condition where this fails? Okay, so remember that the normal force has to be greater than 0, okay, or equal to 0. Normal must be greater than or equal to 0 because it has to be pushing upward. If you get a negative value for the normal force, that means your normal force is pulling downwards, which you can't do. Okay, so the normal force must be greater than or equal to 0. Holy crap, this is the most scattered problem solution I've ever done. Okay, so what happens when it's equal to 0? 0 equals mg minus F over 2. So when it's equal to 0, when the normal is equal to 0, that means the force you're exerting upwards is 2mg. And for greater upward force than that, block B is going to lift. Okay, so then B lifts when the force is greater than 2mg. Okay, so you have to exert basically twice block B's weight to get it to go up. And if you do the same analysis for A, for block A, the interesting thing is that you then get this 2 down here, right? Because you got twice the weight, and you've got 2 over there. So what you're going to get then is actually, so for block, this is for block B, okay, which is part A. Yeah, okay, sorry, I deliberately made it, I didn't deliberately make it backwards, but it turns out I made it backwards, okay. So the range of values that cause block B to lift off the ground is part A. Yeah, totally backwards, sorry. And then for part B, which is finding the range of values that cause block A to lift off the ground, I'm just going to totally confuse you by writing A and B for part B. Okay, so part A is getting block B, and part B is getting block A. Now, that's as confusing as it could possibly be. Okay, so we're going to get the same equations coming through for block A. We're going to have F over 2 going upward, okay, plus the normal force on block A. And then we're going to have, let's see, so we're going to have a, wow, let me figure this out. Okay, so minus, and then the mass of block A is 2mg, okay, and that's going to equal 2m times the acceleration of block A. Okay, and so that's just taking this equation for block B and converting it to block A, which means just double. And it's a different normal force, right? But it's still, you know, we're still representing it with n, okay? So we're being a little wrong here, okay? So then the condition that basically we have, if A equals 0, then the normal force has to be greater than or equal to 0, okay? So we plug that into here, or, you know, what we say is at the critical case where n equals 0, so at the boundary of this, then what you get is F over 2 minus 2mg equals 0. And so then what you get there is the critical case is F equals 4mg. So then the answer is that A lifts when F is greater than 4mg. Okay, I apologize. This is horribly done, but there you go. There's your answer. Yeah, so anyway, that's that problem.